So number 2 looks really scary, but it's really not. You just have to remember that the left always has to equal the right, which will make a lot more sense in a second. So I'm going to need to say that x needs to be multiplied by each of these terms, and then I do the same thing with my negative 2. So x times x cubed is x to the 4th, x times kx squared is k times x to the 3rd, and x times negative 8 is negative 8x. Now I'm going to do the same thing with the negative 2. So negative 2 times x cubed is negative 2x cubed, negative 2 times kx squared is negative 2kx squared, and negative 2 times negative 8 is positive 16. So that's going to be equal to everything that's on the right. Now here's what I'm talking about when I say left has to always equal right. So the matching terms on each side need to be equivalent. So for instance, the x squareds on each side, those portions need to be equal. So I could set up this equation and then solve for k. Now I can see that I divide by x squared on each side to cancel that out. Then I just have negative 2k equals negative 14. So to get k by itself, I just divide by negative 2 and I get k equals 7. Just like that. Now be careful because they might try to trick you this way. Let's say I wanted to use the x cubed term instead, because I see there's a k there. I can do that, but I need to make sure that I also see there's another x cubed on the left-hand side, right over there. I can't just pick one of those terms. I have to pick both of them to be on the left. So if I write my equation for left equals right now, this is what it would look like with x cubed. And you could also use that to solve for k, but it looks a lot yuckier, so I used the x squared term, but both are fine.